we move on to measures of dispersion, statistics. Okay, we are beginning with statistics now. You have done in lower classes measures of central tendency. What are they? Mean, median and mode. They are said to be the measures of central tendency because they measure the nature or behavior of a given frequency distribution towards the center of the distribution. Because you will remember, mean is what? Mean is always the center, isn't it? Mean means average. Suppose 30 and 90. Average is 30 and 90. Average is how much? 60, isn't it? That is 30 plus 90 by 2 generally we do. So 60 is actually midway between 30 and 90. So it is at the center. Similarly, median. Median measures 50% mark of the distribution. That means if median value is suppose 60, it means suppose if it is related to marks of your class. Okay, it is related to marks of your class. Then suppose the median mark is 60 and there are, how many students will I take? 100 students suppose. Okay, there are 100 students in your class and the mean marks of a certain subject is 60. What does it mean? It means that 50% of the students of the class have scored marks less than 60 and the remaining 50% have scored marks more than 60. 50% of 100 students means 50 itself. That means 50 students have scored marks less than 60 and the remaining 50 students have scored marks more than 60. So median is also a central tendency because it gives me a central value of the distribution, the tendency or the behavior of the distribution towards the center of the distribution. Similarly, mode. Okay, so mean, median, mode are the three measures of central tendency which you have done in lower classes. Now we move on to measures of dispersion. Dispersion, as the name suggests, dispersion means scatter or spread of a distribution. Okay, spread of a distribution. Now, when do we particularly need this? Suppose there are three sections in a class, A, B and C. Okay, arts, science, commerce or whatever. Instead of taking so many people, I am taking only 5 people. 5 people have appeared for a test, suppose. And the values are 1, 5, 9, 13, 7 in this class. Whereas in this it is 3, 6, 9. It's not necessarily marks, it can be anything. You can just consider them as values as such. And you have values over here, suppose 7, 8, 9, 10 and 11. Now, in all the three cases, you can check and see the value 9 will be the mean as well as the median of each of these series that is given to you. You can check and see. Okay. Generally, mean is the central value, so obviously the value at the middle, provided it is equally distributed. Of course, it is equally distributed because here there is a difference of 4 units, isn't it? Here there is a difference of 3 units and here there is a difference of 1 unit. So, if it is related to a class, suppose, okay, that means the average marks of this class is 9, average marks of this class is also 9, average marks of this class is also 9. Does it mean that the three classes, the three sections of a particular class, suppose class 11 itself, their performance is the same? No, it is not the same. Why? Because notice here in the first case, here there is a gap of 4 units. This is 1, 2, 3, 4, 5. Okay, 9 over here, 13 over here, 17 over here. Okay, in the next one, 3 is over here, 6, 9, 12, 15. Okay, and the next one, 7, somewhere here, 8, 9, 10 and 11. Sorry, 11. So what do you notice? Here the spread of the values is more here the spread of the values is lesser, and here the spread of the values is the least. So even though average, if I consider marks, average marks obtained is 9, this is has the least spread and this has the greatest spread or dispersion. Okay, practically speaking, suppose in the art section the lowest marks, suppose in maths itself, is 30. Okay, and the highest marks is, what shall I take, 90. Whereas in another section the lowest is 40 and the highest is 80. What is the average? What is the average of 30 to 90? It is definitely 60. Okay, this is the average, 60. Similarly, average of 40 and 80 if you consider, then also the average is 60. But notice the difference. Yes, it does not mean that both the classes have performed. The performance level is the same. No. What is the difference? Here the spread is much more. That means there are children who have got marks very, very less, and there are children who have got marks very, very high. So this group over here is not a very consistent group. Okay, this group is an inconsistent group, or you can say it is less uniform. The uniformity is less. Whereas this group, they are more or less concentrated towards the average. That means they are more or less in and around the average. So this group, the spread is more. You can say the children over here are more or less of the same ability, or you can say they are a homogeneous group, or you can say they are a consistent group. So this is the reason we need to have measures of dispersion to give a better idea of various distributions. Always the measure of central tendency does not give us it is not a good statistic to determine certain things. So in that case, measures of dispersion help a lot. So what you have to remember is, more the dispersion, more dispersed implies less consistent, or you can say less homogeneous or less uniform. Okay, so the lesser the dispersion, the more consistent is the group, the more homogeneous is the group, or the more uniformity is there in the group. I'll write uniformity. Okay, so this is the main purpose of measuring using measures of dispersion. Now we have different types of measures of dispersion. We discussed that. What are the types of the measures of dispersion? One is, how far can I write till here? Okay, one is your range. This is almost obsolete. Then is your quartile deviation, also known as semi-interquartile range. And besides that, you have the, I'll extend it that side, mean deviation. Okay, mean deviation, which can be about the mean of the distribution, or it can be about the median of the distribution. Okay, and the most important one is the standard deviation. This is mostly used and the most important one. Okay, So basically 4 types. One is there's one more, of course, absolute deviation is also there, but it is hardly used. Okay, one more I can branch out from here. That is absolute deviation. Absolute deviation means the modulus value is taken. Okay, so this is not that important. Range is hardly used because range, as the name suggests, it is the difference. It is the difference between the highest value and the lowest value. Okay, so this has many flaws, many disadvantages, because generally what happens is, like as I said, 30 and 90. Okay, it may be that most of the children have got marks close to 90, but maybe only two of them have got towards the 30 mark. Okay, one has got 30 and another one has got suppose 32. So you can see there's a big gap over there in between, isn't it, where there is a, like, what I mean to say is, can I draw here? Yes, the lowest is 30, there's another child getting suppose 32, there's no one getting in 50s and 60s, and there are children who are getting 73, 76, 82, blah blah blah, and finally 90. So this group is more packed up over here, but because of these two or maybe some more children, the range is becoming much more. There's a big gap over here, isn't it? So it does not give us an accurate measure of dispersion, because you cannot say that the group is consistent or inconsistent, because it is more concentrated on this side and less on this side. The judgment will not be perfect one. Okay, so therefore range is not used. Quartile deviation is sometimes used. Okay, mean deviation also not very much used, but still sometimes we need it. But standard deviation is widely used, the most important one of all. Okay, and for comparing two or more distributions, we move on to, as I was saying, that is when we want to compare two distributions which have two different units. Okay, two distributions are given. One is a distribution of weight and the other, I took it as an example, one is a distribution of weight, that means weights are given to you, and another distribution is there where heights are given to you. I label them as X and Y. Now definitely they have different units, isn't it? Weight has units of pound, kilogram, and height has units of, it can be in centimeters, it can be in feet, anything. So we want to find out which is a more consistent variant, whether weight is more consistent or the height is more consistent for a given set of people. Okay, we call it sample. Okay, so in that case what we calculate is, since two different units cannot be compared as such, okay, so we convert it into a ratio so that there is no unit, and comparison of that ratio gives us an idea of the consistency. What are the different coefficients of dispersion? One is coefficient of range, which I haven't written because we hardly use it. Another one is coefficient of quartile deviation. That means for each of the measures of dispersion that you have a corresponding coefficient. Okay, coefficient of quartile deviation, coefficient of mean deviation, coefficient of standard deviation. Coefficient of quartile deviation is given by Q3 minus Q1 by Q3 plus Q1. What is Q3? Q3 is the third quartile of the distribution. Okay, Q3 is the third quartile of the distribution. Q1 is the first quartile of the distribution. I hope you remember how to find out the quartiles. Anyway, we will recapitulate. So notice basically this will be in, suppose I am doing it for weight, this will be in kilograms, this will also be in kilograms. So basically the unit will cancel, it will become a ratio, that is there will not be any unit. So this will be the coefficient of quartile deviation for weights. Similarly for heights, I will calculate the coefficient of quartile deviation, that is Q3 minus Q1 for heights, Q3 plus Q1 for heights. That will also get converted into a ratio, and then we will compare which is more. Okay, this is more often used, that is coefficient of standard deviation, which is also called coefficient of variation. Later on I've written over here in capital letters in the subsequent lines. I hope you can see that. Okay, in short you can write over there CV. You can write your CV. CV is coefficient of variation. It is nothing but coefficient of standard deviation. Okay, C dot V. Okay, so CV is equal to SD. SD is standard deviation by mean. Mean you have to calculate for the distribution. Standard deviation has to be calculated for the deviation and into 100. That means we are converting the ratio of standard deviation and mean of that distribution into a percentage, isn't it? We are expressing, that is what I've written below, that is SD is expressed as percentage of the mean. The standard deviation SD in the numerator is expressed as percentage of the mean, isn't it? That is, we have to find out the standard deviation of the distribution, we have to find out the mean of the distribution, and then we do into 100, that is, we convert it into a percentage. So in that case, what will we do? As usual, we will find out the SD of X, and we will also find out the mean of the X distribution, that is X bar, suppose. Okay, that is the mean. From there, we will get coefficient of standard deviation, that is this one we will get, which is also termed as coefficient of variation. Okay, how will we get it? That is, we are going to use the formula CV of X, we will get from here, and that will be some value. Suppose I have denoted it by star as a percentage. Okay, similarly SD of Y we will also get the mean of Y, mean of the Y distribution, that is mean of the heights over here. So that will give us the mean of Y. From there we will get coefficient of SD, that is we will get the coefficient of variation of the Y distribution, and that is suppose denoted by hashtag. Some value you got, okay, some value you got. I did not write any value as such. I am denoting it by the symbol hashtag. So in that case, I am getting CV of Y as some hashtag percentage. Okay. So now how will you compare? That is the main thing, how you will compare. So suppose coefficient of variation that for X, that is CV of X, which is expressed as star percentage. I've written over here CV of X is suppose greater than CV of Y, that is coefficient of variation of X is greater than coefficient of variation of Y, and in other words, star percentage, which was expressed as a percentage, is more than the hashtag percentage value that you got. What does it mean? Greater CV means, why is this greater? Because numerator is greater, isn't it? Greater than numerator, greater will be this value. So therefore that means standard deviation, or in short the deviation is more. So that means X is more dispersed. So that will be your conclusion. X is more dispersed. In other words, deviation of X is more. And since it is more dispersed, that means it is less consistent. That means here we took X as weights. So obviously weights are less consistent compared to heights. And this is practically obvious because you know weights are very much fluctuating and it does not depend on age nor on height. It is not within the control of anyone. So X is very much less consistent compared to heights. Height is to some extent related to age, and of course genetic thing is also there. Genetically also, genetic factor is also there. So, but as such, this will be your conclusion. Two distributions are given. You will convert them into percentage, that is you will find out the CV, coefficient of variation, and then since they get converted into the same units, that is as a percentage, so comparison is much more justifiable, and so we compare and we write the conclusion that X is more dispersed if its CV is more, and if it is more dispersed, that means it is less consistent. Next we will move on to calculating the measures of dispersion. How to calculate the different measures of dispersion? That is mainly we will do quartile deviation and standard deviation. Those two are the main things that are there in your syllabus. So those two mainly we will do, and little bit of application of comparison using coefficient of variation. Okay. one by one we will calculate the measures of dispersion. We begin with calculation of quartile deviation. As the name suggests, quartile deviation, yes, it is, I had written it earlier, it is Q3 minus Q1 by 2. So basically we need to know how to calculate the quartiles, especially Q1 and Q3. I suppose you will agree that we have three types of distributions. One is your discrete distribution, where you have simply values of x given, x1, x2, x3, so on. Okay. Then you have ungrouped distribution, ungrouped frequency distribution in fact, because this has frequencies given. Here there is no frequency. And this group distribution also is a frequency distribution because frequency will be given. Ungrouped distribution is a what kind? That is, you have a table like this for suppose, where x values are given as x1, x2, x3, dot dot dot, and the corresponding frequencies are given f1, f2, f3 and dot dot dot. So this is an ungrouped frequency distribution. Grouped frequency distribution is where you have class intervals given and frequency given. Class intervals like for 0 to 5, okay, 5 to 10 and so on. And frequencies, whatever values are given. Okay, so these are the three types of distributions that we come across. We will see how we will calculate the quartiles in each of the cases. You have done earlier, but probably you've forgotten. This you haven't done, but I think this and this you have done. Okay, so for a discrete distribution, now what is a quartile? I hope you remember that. Quartile means what? It means the quarters into which a distribution gets divided. Okay, so there are basically 3 points which divides a distribution into quarters, into 4 equal parts. Okay, there are 3 points which divides a distribution into 4 equal parts, and they are the quartiles. What does it mean? It means that this entire distribution, if I consider it as 100% of the distribution, then 25% of the distribution is below Q1 and the remaining 75% is above Q1. Q2 is nothing but the median. Okay, as I said, 50% of the distribution is below Q2 and the remaining 50% is above Q2. And Q3 means, I hope you can see, yes you can, I'll shift it a little more that side. And Q3 means that below there is 75% of the distribution and above there is only, I think you cannot see, I'll shift it a little more that side. Above it is only 25% of the distribution. Yes, so this is what is meant by quartiles. In fact, suppose the quartile value, Q1 value is, what shall I take? Q1 value is 32. Q1 is equal to 32, suppose. What does it mean? Q1 is equal to 32. It means that, and the total distribution strength. Okay, total distribution strength is, suppose, how much will I take? 120. Okay, total strength is 120. That means it is for a class itself. Suppose there is a class of 120 students and marks are being calculated. First quartile is 32. What does it mean? It means 25% of the students have got marks less than 32. 25% of the Q1 is equal to 32 implies 25% of students or total strength of the distribution have got marks less than 32. 25% of the total strength means how much? 25% of 120. 25% of 120 students, what will it be? That is 30, isn't it? 25% of 120 have marks less than 32. Okay, which means 25 out of 100 into 120, that is 30 students have marks less than 32. Similarly, Q3 means Q3 is suppose 90. Okay, Q3 is suppose 90, and that means what? 75% of the students. This is Q3. This is corresponding to Q3 over here. Look at your diagram that you have over there. Q3, this is your Q3. It means 75% below it is 75%, above it is 25%. So it means that 75% of the students have marks less than Q3. How much did I suggest? 90, suppose. 75% of the students have marks less than 90, and the remaining 25% have marks more than 90. So like that. Anyway, we'll not discuss all that. You are supposed to be knowing it. Just I wanted to recap what is meant by quartiles. What is the geometrical meaning and the practical meaning of the quartile values that we get. Here we are concerned with finding the measures of dispersion. That is, we'll find out Q1, Q3, and because according to definition, quartile deviation is, what did I say, Q3 minus Q1 by 2. So let us find out, let us write the formulae to calculate. Okay. So let us see what are the steps involved. Here it is a discrete distribution. The first step will be you have to arrange in ascending order because they are the cutoff points, 25% below, 25% above, or 75% below, 25% above. So they have to be the definite order, and we arrange it in ascending order. That is the first step, where n you will get as the, can you see? I think you can see. I'll shift it a little more this side, where n is the number of values that are there, or we say they are the number of observations. Number of values or number of observations. Then comes the next set of, the actual set of formulae. Step 2, Q1. Q1 is, the first quartile Q1 will be the value at n plus 1 by 4th position. Okay, it will be the value at n plus 1 by 4th position because it's dividing it into 4 parts. That is why we divide it by 4. And Q3 will be given by value at, it is 3/4. So it's 3/4 of n plus 1th. So it is the value at 3 by 4 n plus 1th position. Okay. So this is the scheme of calculation. For ungrouped data, here we don't have to arrange in ascending order, fortunately. Here you don't have to arrange, just you will get n. N is your sum of the frequencies. It is also actually the number of observations, but we denote it by capital N because it is obtained by adding up the, I hope you're familiar with this symbol. Okay, N is the sum of the frequencies that you have over here in this table. F1, F2 plus F3 you will do, that will give you N. And then you will get Q1 and Q3. Q1 will be the value at n by 4th position, and Q3 will be the value at 3n by 4th position. Okay, so this is for what do you call it, ungrouped frequency distribution. For a grouped frequency distribution where class intervals will be given. Okay, what will we do? First and foremost, we need to identify where the quartile is located, or the class interval in which the quartile is located. So there the first step will be, I'll shift that side. So there the first step will be identifying the step 1. First step will be, you will obtain the quartile class. That is the class containing the desired quartile. Okay, the location. That will give us the location of the class containing the desired quartile. How will we get it? Okay, now depends on what we are finding, whether it's Q1 or Q3. If it is Q1, then it will be the class at 4 parts it will divide. So it's n by 4th position. N has the same meaning, it is summation f. Okay, and if it is Q3, then it is class at 3n by 4th position. Class means class interval. Okay, this is the first step. Whether you're finding Q1 or whether you're finding Q3, first thing is you have to find out where the quartile class is, or which class contains the desired quartile that you are looking for. Okay. Then comes calculation of the value of Q1. I won't say this is Q1, please write over here Q1 class, Q3 class. Class means class interval. Okay. First thing is finding out the quartile class, that is Q1 class and the Q3 class. Next step will be the calculation part. I'll about this part so that, because it will need a lot of space. So we have found out the quartile class here. Now we will move on to calculation of the quartiles. Okay. The formulae that will be used are, I'm writing as step 2. Okay, what are the formulae to be used? Q1 value will be given by L plus n by 4 minus CFB by FQ. And if it is Q3 will be given by L plus 3n by 4 minus CFB by FQ. F suffix Q, not F into Q. Okay, just a symbol. C is the main letter. FB is just a suffix below, not a product. Why? I'll mention that. What are these? Okay, this is F. N by 4 and 3n by 4 you already know. What is CFB and what is L? Where L stands for lower limit of the quartile class. Okay. Oh, sorry, I forgot to write into H over there. I'll write it at the back, no problem. Into H. Don't forget this. H is the length of the class intervals. They are generally the same. Okay. N as usual stands for summation F, sum of the frequencies. C, capital C, I've deliberately used this symbol because it will help you to remember better. It is, I have used this because it stands for the cumulative frequency before, that is why I have used the suffix FB, and C stands for cumulative. Okay, frequency before, that is why I have used suffix FB. So F for frequency, B for before. Cumulative frequency before the quartile class that you will get in step 1. Cumulative frequency before the quartile class. And F suffix Q stands for, F is for frequency, Q is for quartile class. Q is just a suffix. Frequency of the quartile class that we are taking. Okay. So this is the mode of calculation. One more thing I forgot to mention is where you have written this one, ungrouped data. No, sorry, grouped. No, right? Yes, ungrouped distribution you have written in the second subpart. Yes, ungrouped frequency distribution. There I didn't write anything in the step 1. There please mention over there. Step 1 will be over there. You have to find the cumulative frequencies. Because without finding the cumulative frequencies, you cannot proceed further. That is why cumulative frequencies have to be found, which will help us. We don't arrange in ascending order. We find out the cumulative frequency because that will give us the exact position of. I hope you remember what cumulative frequencies are. Yes. After that, you are writing, I think, after that you have written capital N is summation F, isn't it? So, there just before where you have written capital N is equal to summation F, there I think I left a gap over here as far as I remember. I don't know whether you have also left a gap. So, if you have left a gap over there, write step 1, cumulative frequencies. Just like for discrete, you have written arranging in ascending order as step 1. So here step 1 will be cumulative frequencies, and then step 2 will be finding the values of Q1 and Q3, where Q1 is value at n by 4th position and Q3 is value at 3n by 4th position. Okay. And then this is for the group distribution that I am discussing. This is your step 1 where you are finding the quartile class, what is the class where the quartile is located, and then you calculate, then you shift to this where you calculate the values of the quartiles. Let's do a few examples on how to calculate the quartile deviation for a given distribution. Suppose you are given a discrete distribution. Okay, example 1, the values. Obviously, the question is find the QD for the following set of observations. What are the observations? Okay, I hope you can see. Yes, you can. Okay, the values are, suppose, 29, 12, 26, 19, 24, 36, 21, 33. Can you see further? Oh, I think I'll write this side. One more value I think I'll manage to fit in, 35. Okay. So 29, 12, 26, 19, 24, 36, 21, 33 and 35. Now this is a discrete distribution because you can see values of the variable is given. Values of x are given. So what do we have to do? If you don't remember, refer to the steps that you have written. The first step is what? Finding the, first of all, writing it in ascending order. Okay, we write it in ascending order. That is so we are writing in ascending order. Values lowest is what? 12, isn't it? 12, then it's 19, check, then it is 21, then 24, then 26 is also there, 26, then you have 29, then you have 33, then you have 35 and finally 36. 12, 19. There are how many observations? Number of observations, number of values, whatever you say. Number of observations is, which is n of course, is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Check whether you have 9 of them. 3, 4, 5, 6, 7, 8, 9. So you haven't missed out anyone. So it is alright. So number of observations is 9. What is Q1? Q1 is Q1, refer to the notes that we have written. Q1 is the value at n plus 1 by 4th position. Okay, that means it is the value at 9 plus 1 is 10, 10 by 4th position, that is at 2.5th. Can you see? Yes, 2.5th position. That means it is the value at this little more than halfway beyond the second position, isn't it? 2.5th position means it is a little halfway beyond the second position. That is why you have 2.5th position. So therefore, what will you do? So therefore, that is what you will write. This is the value at second position and a further, so plus halfway between the value at the next position minus the value at the second position, isn't it? 2.5th position means what? Somewhere is the value here. This is the second position, this is the third position. So it has to be somewhere in between over here. So the difference between these two values halfway through will be the location of the required quartile value, isn't it? So therefore, what is the value at the second position? It is 19 plus little more half of the gap between these two. That means it's 21 minus 19. Third position value is 21. Here it is 19. So it's 19 plus how much? How much is the difference between 21 and 19? It's 2. So it's halfway of 2. That means it's 1. So the value is 20. This is Q1. Okay. So this is how we calculate Q1. Similarly, how will we get Q3? So Q3 over here will be the value at this position, 3/4 of n plus 1th position. That means it is how much? It's going to be now 30 over here, 3 into 10. So it's 30 by 4th position. 30 by 4th position means what? 15 by 2. And that means it's going to be, that is at 7.5th position. Yes, value at 7.5th position. So, can you see? Yes, you can see 7.5th position. So therefore, what will it be? It will be the value at 7th position and a further of halfway between the next value and this value. Okay, so between, first let us check 7.5th position is where? Let's check that and mark it over here. 7.5th. 1, 2, 3, 4, 5, 6, 7. Yes, check 1, 2, 3, 4, 5, 6, 7. 7.5. This is your 7th position and this is our next position. So 7.5th position will be somewhere over here. So therefore it will be halfway between those two values. Okay. So it will be value at 7th position plus halfway between the gap between, you write it as value at 8th position minus value at the 7th position. It's not necessary that you have to write all this in words. Just you write it is at 7.5th position. Mark it over here. So you know it's going to be 33 plus half of the difference between these two values over here. Okay, so it's 33 plus half of the values between this and this. So in the next line you are writing 33 plus half of value at 8 minus value at 7. So again, how much will it be? This is going to be 33 plus half of 2. That means it's going to be 33 plus 1. That means the value is 34. So this is your Q3. So therefore, what is the quartile deviation? We have to find quartile deviation. Don't forget QD. That is the quartile deviation is equal to half of Q3 minus Q1. And therefore, it is given by half of 34 minus, what is the value I got? 20, I think. Yes, 20. 34 minus 20. 34 minus 20 is how much? 14, isn't it? So it is half of 14, and therefore the quartile deviation is 7. 7 units of deviation. So this is how we calculate for a discrete distribution. So remember to mark it over here in the values that you are writing. Okay, don't forget that. It's not necessary that you have to write this line in details, but this one has to be shown that you are getting 7.5 at position, and therefore you can write directly. That means 7, that is 33 plus halfway of these two difference. Similarly, it was I think 2.5 at position, so it's 19 plus halfway of the difference between 21 and 19. So that is how we got it. So this is how we calculate quartile deviation, or rather you can say how to calculate quartiles for a discrete distribution. Next we move on to calculating quartiles for a distribution which is not discrete, that is which is ungrouped frequency distribution. Next we move on to calculating quartiles for a frequency distribution. Two types of frequency distributions are there. One is your ungrouped frequency distribution and the other one is grouped frequency distribution. Okay, so we'll do the ungrouped one first. Let's take simple values. The question is find the coefficient of quartile deviation for the following table of values. Okay, what are the values? Suppose I'll take small values for the sake, it will help to understand better. X values are 5, 15, 25, 35 and 45. Frequencies are 10, 20, 40, 20 and 10. Okay. So this is the table that is given to you. What is the first step? Please refer to the table. I refer to the theory part that I had given. I have told you the step 1 will be calculation of cumulative frequencies. Why we calculate cumulative frequencies? We'll come to that. So I'm writing it as solution. I'm rewriting it. That is X values are 5, 15, 25, 35, 45. Frequencies are 10, 20, 40, 20, 10. We'll calculate cumulative frequencies. Cumulative frequency. Cumulative frequency, how to calculate? 10 plus 20 will give you this 30. 30 plus 40 will give you 70 plus. Okay, 70 plus 20 will give you 90. 90 plus 10 will give you 100. So this is your N. Notice summation F is the same, which is your N. It has to be the same. If it is not same, then you will have to check where you went wrong. Okay. So now we'll do the calculations. Coefficient of quartile deviation is what? Q3 minus Q1. Find the QD, both. QD and coefficient of quartile deviation. I think we'll do both. Find the quartile deviation and the coefficient of quartile deviation for the following distributions. Now, I've given the formulae already. Please check and see how to calculate Q1. Now, what does this mean? This table that you have found out cumulative frequencies. That means there are 10 values or 10 positions where you have 5. There are 30 positions occupied by 5 and 15. Okay, and there are 70 positions occupied by 5, 15 and 25, where the first 10 is occupied by 5, the next 30 is occupied by 15, the next 20 is occupied by 15, and the next 40 is occupied by 25. Okay, so there are below 35 there are 90 values which have been occupied by 5 in the 10 positions, 15 occupying the next 20 positions, 25 occupying the next 40 positions, and 30 occupying the remaining 20 positions. I hope you remember the interpretation of cumulative frequency. So that is what I tried to recapitulate. Now the calculations. Can I write that side? Yes, I can. Look at the table that I had given you. What is Q1? Q1 is the value at n by 4th position. So I think I'll write this side. Q1 is equal to value at n by 4th position, and that is equal to value at 100 by 4th position and that is equal to value at 25th position. Okay, so up to 10th position you have 5, up to 30th position you have 5 and 15, out of which from the 11th position to the 30th position is occupied by the number 15. Observe very carefully. Yes, from the 6th position onwards up to the 10th position, up to the 10th position you have the value 5. Yes, from the 10th to the 30th position you have 15. So 25 will be, I'll use a different pen, 25th position will be somewhere here. This is your 25th position. Okay, so 25th position is occupied by which number? Up to 10th position you have 5. So after that it is occupied by the number 15. So therefore the value at 25th position is 15. This is your Q1. Next comes Q3. Q3 is the value at 3n by 4th position. That means it is the value at 3 into 100 by 4th position. Okay, and therefore it is equal to value at 75th position, because n by 4 is as it is 25, so 3 into 25 gives 75. So 75th position. So up to the position 70 is occupied by the numbers 5, 15 and 25. Okay, so where, that means 75th position is somewhere here. This is your 75th position. Okay, so 75th position will be, up to 70th position is occupied by 25. So the 75th, from the 71st to the 90th position is occupied by the element 35. Okay, so therefore the value at 75th position is, I used green and used green again, is 35. So this is your Q1 and this is your Q2. Hence, what is QD? Do I have space here? Yes. So what is QD? I will write it that side, quartile deviation. Therefore, quartile deviation QD is what? The formula is Q3 minus Q1 by 2, and therefore it is, what is Q3? 35 minus 15 by 2. 35 minus 15 is your 20, so 20 by 2 is your 10. This is one answer. And here I will write, can you see? No, from here I will write coefficient of quartile deviation. The formula is, I've written it earlier already, it's Q3 minus Q1 by Q3 plus Q1. Q3 minus Q1 means 35 minus 15, and this is 35 plus 15. Yes, 35 minus 15 is your 20, and 35 plus 15 is your 50. So you are getting 20 by 50. So it's 2 by 5. So your answer is 0.4. This is your answer. For which part? For coefficient of quartile deviation. Okay, so this is your quartile deviation and this is your coefficient of quartile deviation. We'll do one more example on this where you have a frequency distribution. Okay. The next example under the same category, that is, you have a frequency distribution which is where class intervals are not given. That is, you have a ungrouped frequency distribution. Okay. So this is the question already written over here. This is age given and number of members of that age given. So age 20, there are 3 of them. Age 30, there are 61 of them. Age 40, there are 132 of them, and so on. So here we will find out what is the quartile deviation. Since this is an ungrouped data, we will find out the first step is what? Calculating the cumulative frequencies. We label them, I write it as solution. We label the variable as x, that is age is your x, and the values are 20. So this is the next example under the same category where age is given and number of members under each age group is given. Okay, so let's tabulate it. This is obviously, you can see this is a frequency distribution because this is your frequency and this is your values. And of course it is not grouped because class intervals are not given. It is an ungrouped frequency distribution. So we have to find out the cumulative frequencies. X values are 20, 30, 40, 50, 60, 70, 80. Frequencies are 3, 61, 132, 153, 140, 51 and 3. Let's calculate the cumulative frequencies. Okay, this is 3. 3 plus 61 we will do now. 3 plus 61 gives us 64. 64 plus 32. Now you don't have to put these arrows. Just because I'm explaining, that is why I'm putting. You know how to calculate cumulative frequencies, I guess. 64 plus 132 gives you how much? 196. 196 plus 153. 318. Oh, sorry, I forgot that I'm not taking a live class. Anyway, 349. Okay, 349 plus 140, that gives you 489. 489 plus 51 gives you 540. 540 plus 3 gives you 543. Check and see whether it's correct or not. Summation F, add up. It will give you 540 definitely, I'm sure of that, because this and this has to be the same. Now what you will do is, you will calculate the values of Q1 and Q3. Q1 is what? Can you see? Yes, you can see. Q1 is equal to value at what did I do? N by 4th position. N by 4th position. That means it is value at 543 by 4th position. Can you see? Yes, I'll shift it a little more that side. Okay. So this is equal to value at 543 by 4 gives you how much? It won't cancel totally. 135.75 if I'm not wrong. 135.75th position. So 135.75th position. Where is it? It's somewhere here, isn't it? More than 64 but less than 196. So this will be 135th position will also be here. 135.75th position also will be taken up by the same element 40, because up to 64th position is the value 30. From the 65th position you have the value 40. So 135th position or 135.75th position will all be occupied by, that means 136th position also will be occupied by 40 itself. So Q1 value is 40. Oh, this is not the answer. So this is the value just. Next, Q3. Q3 is the value at 3n by 4th position. That is equal to value at 543 by 4 into 3th position. That means it's this into 3. How much is it? 135.75 into 3. That means it will be this will become 25 and here it will be 7. So it will be 407.25th position. Check and see the product. Okay, 407.25. 407. Where is this? Is 349. This is 489. So it's more than 349 but less than 489. So therefore here will be your 407th position. You can write 407.25th position. I didn't write because whether it's 407th position or whether it's 408th position, it will be taken up by the value this itself, that is 60. 60 is occupying up to 349. Yes, 349th is occupied by the value 40. 350th position onwards you have 60. 350, 351th position, 352th position, till 400th position, 407th position, 408th position, 410th position. All of these up to 489th position will be the element 60. So 0.25th position will also be taken up by 60 itself. There is no other option. So the value over here is 60. So what is the quartile deviation and the coefficient of quartile deviation? So where will I write? I will write it here. QD. QD is equal to Q3 minus Q1 by 2. Can you see? Yes, you can see. So it is 60 minus 40 by 2. That means it is 60 minus 40 is your 20. So it is 20 by 2. That means 10. Don't forget to write the unit 10 years. Because here you have a unit. Okay. And coefficient of quartile deviation I'll write over here. Coefficient of QD is Q3 minus Q1 by Q3 plus Q1. Q3 minus Q1, we already got it as 20. Nevertheless, I'm writing it once more. 60 minus 40 by 60 plus 40. That means it's 20 by 100. 20 by 100, that means it is going to be 0.2. This will not have a unit because it is the ratio of age and age. Age by age. Numerator is also age, denominator is also age. It's just a ratio. So this will not have any unit. Whereas here, numerator is the difference between ages. This is actually years. Q1 is 40 years, Q3 is 40 years. Okay, 40 years of age. Q3 is 60 years of age. And this is your coefficient of QT.